Alrighty, everyone, we'll have a look at this question C, and it's talking about Frank, who's trying to prove Pythagoras' theorem, and he's come up with a couple of relationships down here, where he's shown this relationship here, and we're being asked to show this relationship in a similar way. So let's look at those sides. QR is this side, RX is this side, and PR is this side, and they all have this angle in common. So when we're talking about QR and XR, this would be adjacent and this would be hypotenuse. When we're talking about QR and PR, this would become adjacent and this would become hypotenuse because that's the longest side. So using that, we'll see what we come up with. So I'm going to write down cos of the angle that we marked, which is this angle here, QRP. QRP is equal to, we'll say RX over QR, and then I'll write cos angle QRP is also equal to QR over PR. And because both of these fractions are both equal to the same thing, we can write those fractions as equal to one another. So I can say that Rx over QR is equal to QR over PR. So I'm going to start solving this by times both sides by QR, and that will cancel those two out and leave us with QR squared on one side and over PR, that is, and that's equal to RX on the other side. Now I can do a similar algebraic move, times both sides by PR, and they cancel out on that side and leave us with QR squared equals RX times PR, which is what we're asked to do, and so that's it. Alright, next question is asking us to use the results above to prove Pythagoras' rule for this triangle. So let's go up and have a look at that triangle. Just get rid of all this. So if we're proving Pythagoras' theorem, we'd be looking at the two short sides A and B and the long side C. So I'm going to start by writing out Pythagoras' theorem. So I'm going to write A squared plus B squared equals C squared. Next thing I'm going to do is write out what each of the letters are. So this side here is PQ. So I'm going to write that underneath, PQ squared. B is QR. So I'm going to write that out underneath, QR squared. And that's equal to PR squared. PR squared. Now this isn't showing anything, but if I write down this, and after some working it ends up being this, then I've showed something. So that's what I'm going to do. I'm going to write out PQ squared plus QR squared, and then write out something else that's equivalent to. Now they said use our last question, and in our last question we have these two bits here which show us what PQ is. So it says that PQ is PX plus PR, so I'll write that out. PX plus PR times PR, and we don't need to write a squared because our statement up here says that it's PQ squared is equal to PX plus PR. Over here we've got QR squared, and so that's equal to RX plus PR. So I write that plus RX plus PR. Okay, so we've got two similar terms here, so we'll factorise those out. So I'll write PR and then PX plus, now we've got that right, RX PR, yep, so PX plus RX. And at this stage we'll go back to our diagram. It shouldn't be plus there, that should be times, that's why I'm getting confused, times. We'll just go back to our diagram. This is PX and this is RX, so if you add them together you're actually the same as just PR. So that means that this bit here I can write equals PR. And then that means that I've got PR times PR, which is actually PR squared. And so I've shown that if you start with PQ squared, you end up with PR squared. So we'll write therefore PQ squared plus QR squared equals PR squared. And that's it for those two questions.